Good morning to all of you. Welcome back to Hospitality Engineering. Today we continue Energy Conservation and Energy Efficiency Module 12. Energy, Part 6. High costs and longer payback periods. Let us recap our last video. In previous video we learnt about Type 3 moderate to long payback periods in energy conservative measures. In this video we are going to discuss about Type 4 high costs and longer payback periods. Is cogeneration possible in hospitality industry? It is an excellent way to conserve energy because it recovers additional 25 to 50% of energy that would otherwise be lost to the atmosphere. Used to generate hot water and steam. It can therefore provide a reasonable payback. Once energy-saving and energy efficiency projects successfully implemented and return of investment achieved, then what is next? Renewable energy. Reason for using renewable energy technology is not so much to do with energy conservation, but with using non-fossil fuel generated energy that will reduce overall carbon footprint by reducing CO emissions. Installing alternative, renewable energy technology entails high initial cost and, depending on technology, long payback period. Where is our hotel major energy use? Heating, ventilation, and air conditioning, HVAC. Energy costs for HVAC equipment can be 20 to 50% of hotels' total energy cost. Lower figure. Applicable to smaller unsophisticated hotels in temperate climates. Higher figure. To luxury hotels in subtropical and tropical countries. Let's discuss building characteristics. New buildings, extensions and refurbishments should be designed and built so that heating and cooling losses will be minimal. Sustainable design with a proper balance of aesthetics, accessibility, cost-effectiveness, safety, and security. Superior indoor air quality, based on the specific requirements of the space. Energy-efficient design and performance. Reduced greenhouse gas emissions. Optimal lighting and acoustics. Thermal comfort and appropriate humidity levels. How to match source to load in hotel chiller plant. Equipment is designed to satisfy full load conditions both in winter and summer. Capacity is based on typical day, with peak outdoor air conditions and maximum loads at same time. Equipment operation and capacity for cooling, heating and ventilation should match changing profiles throughout the day and seasons without loss in efficiency. Basic rule: shouldn't move any more air, water, steam or refrigerant than is needed to satisfy load condition. How to decrease the load? You can decrease load by reducing solar load, reducing amount and wattage of lighting, reducing internal thermal load, reducing use of outside air while satisfying fresh air requirements, diverting load to other sources. Peak demand control. Ice storage, which constitutes a shift in load. How to recovery of waste energy in hotel. Heat recovery on exhaust systems. Swimming pool latent heat recovery. Flash steam recovery. Condensate heat recovery. Use of heat pumps. Condenser water heat recovery. Boiler flue heat recovery.
Other techniques.
Building automation systems. Cogeneration and trigeneration. Use of alternative energy sources. We have come to end of this video and hope you have subscribed our channel. If not, please subscribe, like and comment our channel for more training modules. See you next topic on case studies.